Hello to everybody, Marco Beato, Associate Professor in Sport and Exercise Science. Today I want to explain you how to run an independent sample test using JASP. The first part of our analysis will be descriptive. So I need to click here on descriptive, choose the variable that is interesting for me. So in this case, standalone jump baseline, and evaluate our descriptive analysis watching this table. So as you can see, you have 29 valid subject, you have 0 missing data, and you have the mean standard deviation of your sample. I can add also some other information to this analysis. So for example, if I want to know more about the central tendency, I can click here on mode and median and add this information to my table. In particular, because this analysis that we are going to do is a parametric analysis, I need to run a Shapiro-Wilk test. The Shapiro-Wilk test tells us if the assumption normality that is related to the distribution of our data is confirmed. So in this case, the p-value is greater than 0.05, so the assumption normality is confirmed. So I can run a parametric test. Since in this specific case, I'm not very interested to the mode and the median, I will deselect that and I will add a other factor. So since this analysis is related to two groups, is independent t-test, I need to divide my sample based on the group allocation. So I will move the group here in split. And as you can see here, the table will create the information that I've selected. So for example, mean standard deviation and Shapiro-Wilk test analysis for the group A and group B for the variable that I selected. So using the right terminology, we should say that the standalone jump baseline is our dependent variable. The group is our independent variable. So here I have a mean value for the two groups. I can see already there is a difference. The standard deviation at the country is very similar. And I have obviously two information regarding the p-value of the Shapiro-Wilk test that are normally distributed. So I can progress with our second analysis, that is the independent sample t-test. So I'm going to perform exactly the same procedure. So I will move my dependent variable here on the right and my independent variable related to the group here in grouping variable. The software calculates for you the p-value, so we know that there is a significant difference between the two groups, but this information needed to be a bit more supported by other information, because the p-value per se doesn't give us enough information to understand the difference between the two groups in this case. So I need to add also some location parameter. So for example, the mean difference between the two, that is the difference between the mean of the group A minus the mean of the group B. So in this case is 11.5 centimeter. And I need to add also the confidence interval. So the confidence interval can be calculated on the 90%, 95%, or 99%. But usually in sport science, we use 95%. So in this case, on the right of the table, you will have the lower and upper confidence interval. I can add also another information that can support your understanding of the difference between the two groups. It is the effect size. The effect size is the standardized difference between the two groups. And by default, we have a Cohen D effect size. So when is the moment to report this data? You should report the mean, the standard deviation of your sample between the two groups, the p-value, mean difference, and the confidence interval, and the Cohen D. If I want to add some other information, for example, I can add a descriptive plot. In this case, you will see that the plot shows the standalone jump baseline data for the group A and group B. The dot represent the mean, and the two lines that you can see here represent the 95% confidence interval and are exactly the lower and upper confidence interval. I hope this tutorial has been interesting for you. Thank you very much, and please subscribe to this YouTube channel.